Okay, so we are now ready to actually try to start using the package for the Wave 2 analyses. Again, just some messages up top. One of the things I like to do is I like to make this window a little bit bigger, just so it'll be a little bit easier to kind of talk through. And let me also just zoom in. There we go. Just a little bit bigger. Helps me. Let's go one more bigger. There we go. Everything's all nice and big now. Okay, so we don't need to run lines 18 and 19 at the moment. I keep them here just so that in case the package needs to be updated, we can just run this line. One of the kind of nice parts about it is whenever we make any updates, which we probably periodically will to fix different bugs and different formatting issues that I'm sure we're going to run into, you just have to rerun this line. You don't have to rerun the entire install packages script. You only need to run the line that reinstalls it from the repository where the code is stored. Okay, so what the package does first is it kind of gets a lot of things into R's memory so that it can do different analyses and handle different things on the back end that will make our life a little bit easier and makes things run a bit faster. So the first thing is to run the line. Then these next lines 25 down through 42, they do different things. So this first one, it directs where the data is stored on the computer and relative to the current project file. So it's currently in the data folder over here, and the name of that data set is GFS all countries wave 2. And you'll notice that in here, if we go into data, that's exactly the name of it. And it just puts it in memory. So what it does is it creates an object that R recognizes called data, so data directory, which stores essentially the information of data. And the same thing for the name of the data set. Now we just want to actually load the packages. This should run pretty quickly. I suppressed a lot of all the messages that normally are spit out whenever we run load library and load all, which is why you see this capture. Okay, this next thing is called options. These are two settings that are needed for the survey package and the feature package, because these have to do with, first off, how settings internally of the package handle different types of the complex sampling design, and this feature.plan is what is used to help with doing things in parallel so that things run faster. And this handlers global, this is something that is useful for helping print out the progress bars for running the analyses. Okay. This next part is to help identify the number of cores your computer has and how many things that can be done in parallel to help speed things up. And for me, my computer has 16 cores, so I'm currently using half of them, which is 8. We don't want to use all the cores typically, because that makes your computer kind of start to whine really loudly, and it sounds like it's going to explode. Next part is where things start to be really specific to what your paper is. And so it has, very similar to a lot of the Wave 1 analyses, is it has a component of specifying what is your variable. And I cannot stress this enough, this must be a variable name that is in the data set. Nearly all of the Wave 1 or Year 1 variables end in a underscore Y1. So if this does not end in an underscore Y1, something is probably wrong. So in this case, for this example, I'm initially showing you for, let's do, I think, we're going to do happiness, which is happy, and it must be in all caps for Year 1. Now, for the next part, is we set it up so that you can provide what you want your vocal predictor to be named. By default, you can use the, Here it is. So for as a little side note, whenever you type a package name and then do two colons, it will actually give you a list of all of the functions that are available. So here, since my focal predictor is happy, you can just use the default, which is happiness down here with the variable name, what is in the codebook provided as well. You can suppress that by saying false. Or you can do include dot wave. That's true if you want to print out what wave that variable is collected, and that's useful and used other places inside the package, but not here. So you're welcome to use that as the default, or you can come up with your own. So here, I'm just going to use happiness. Happiness. So it's the focal predictor, better name, is happiness, which is a little bit more which is a little bit better name, I would say, than happy underscore y1. It's a fine, just not as necessarily descriptive. You can put as long or as short a name here as you want. Typically recommend trying to keep it not too many words, probably under 30 to 40 characters would be the maximum that I would recommend, just so that it doesn't kind of wrap within any of the tables. Then what you can do is you can add in what label and how you want to describe what the reference value is for that variable. So within the analyses, it is centered and standardized it is centered so that you can understand like how much scores differ from the mean of happiness within country. But this becomes really useful when you have other categorical predictors. You might want to say that it's not just the mean within country, but you might want to say something like responded never, rarely, might be a good way of describing that, depending on what your predictor is. Now, happiness and happy is approximately continuous, where it has scores from 0 to 10. So we're going to treat it as approximately continuous in our analyses. However, if your outcome or if your focal predictor is binary or categorical or nominal in some way, we need to define how it's going to be collapsed. One of the, you can use the default, which get recode, is it recode? To numeric, I believe, is the function. But you can just use whatever the default is for your function, if not. Because if you leave these blank, but you do say it to be categorical, it will, if they're left null, they'll use what are the kind of internals for the recoding, which is recode to numeric. And if, side note for our tricks, if you type in the function name without using the quotation marks or the parentheses, what it'll do is it'll print out the actual code for that function, so you can kind of see what that function does. And so what I want to do, because that will let me, cat is just a way of, is a function that is used to help with printing a lot of times. But anyways, so what that function recode to numeric does is it will take whatever the variable name is. You have to provide it a variable name. It's all that's handled internally. But what happens is it will then recode variables as needed. So like for approved government, what it does is it will take in whatever values are in there, and it collapses values 1 and 2 into a value of 1, and values 3, 4, and 5 into a value of 0. And so these are the internals of what is how every variable is collapsed and recoded to be numeric values for all the analyses. Some of the demographic variables are recoded in other places, but in general it's recoded as it is here. And so if you ever want to look at what these are, just print out the function. I believe we can, wonder if there's a way, print, but anyways, so it will use one of these internals if you need it to, otherwise you can specify them directly. So like for another different outcomes, you might want the responses of 1 and 2 to be collapsed into the upper category, but values 3 and 4 you want to be 0. But for now, it's not. We put in some potentially useful options that you can test if you want to by different ways of handling the categorization and collapsing. What you can do is, instead of treating like some of the continuous variables as continuous, you can actually force it to be dichotomous or binary. Not necessarily the most helpful in all cases, but sometimes it is. And then you can also force it to treat things as continuous, which is helpful for ordered variables, kind of like the life and balance, some of the education. It can be kind of approximately continuous-ish, depending on what variable you're analyzing, and it forces it to be analyzed as continuous. This is something that I will touch on later in a separate video on subpopulation. That's a little bit in the weeds for this initial overview. So this part here, it just kind of puts the name of the variable on each of those lists and vectors so that they're just in there and easier to kind of use. There's several functions called get variables, which kind of does some things under the hood to help with kind of separating what variables are what and identifying them. And this is where we kind of use that default option and the upper and lower value stuff. So what I'm going to do is go back up to the top and start running it. So focal predictor, happiness, which we don't need that. Yeah, I'll keep that in there. Focal predictor, it's happiness. Then put in the reference. It's null, null, false, false, null. Put things in there that need to be in there. Get variables and recode. So now we've kind of finally set things up to now actually run the analyses. This needs to be true. So the first thing we need to do is we need to use those files, all that stuff that we've read in and labeled and listed, to now read in the data. It's called GFS get labeled raw data. So what it does is it reads in the data internally, does a lot of manipulation to put value labels and turn NAs into NA values and different things, so that whenever we print them out, things are a little bit easier to work with. And this can take a second. It's not exactly the fastest, unfortunately. And we're still waiting. Told you it should take a minute. Any minute now. Any minute. And there we go. Data is all read in, and you'll see that now we have this df raw object on the top. That's pretty big. And we can click it and go into the data, and now you see that we have the countries, some new variables were created, different labels were now added. Yeah, that's the data. Now we go on to the next time-consuming part, or the first time-consuming part, and that is running the imputation. Now this is, it takes a minute. What it does is it takes in this vector of variable names called, which I call pred0. That's all kind of like the baseline predictors that are used to predict messiness, specifically at wave 1 only. These are kind of all the variables that are kind of pre-wave 1 mostly, and kind of basic demographic characteristics, along with some information about the survey design, specifically like the weight and the recruitment mode, to account for any modal differences. And what happens internally inside the function run impute is it actually will use basically all of the wave 1 variables to predict almost all the wave 2 variables. It's a little bit more complicated than that because there are some variables that are just 100% missing in some countries. Essentially, we can't use those because there's no information within country about them, so those are omitted, and we handle all of that inside this run impute. And so now when we highlight it and run it, you should be able to just kind of highlight and press run. And this it can take a minute, unfortunately. And by a minute, I mean several hours. This is the first kind of step where I recommend starting this right before you go to bed so that it's done in the morning. And I'm going to now do a time lapse that will speed things up, and I'll be back in tomorrow or later today to show you what the results of running this function is. Yeah, you see that it'll give you a printout of which country it's doing and provide some output in the middle of it. So one thing that you'll notice first is I got this new Windows security pop-up basically saying that RStudio is trying to do stuff with the session information. We need to press allow here so that it can do things in parallel. There might be other times you have to do this throughout the analyses, which is why I try to recommend always starting these things, waiting 5-10 minutes to see if anything immediately breaks, and then you can kind of go on with your day. Okay, I am back after running all of the imputation. It took a minute, and by a minute I mean a quite long minute, but imputation ran, and now you'll see that in the data folder you'll have 23 new files called imputed data object, the name of the country, and then in imp 20 for the number of imputations generated. One of the things I recommend doing, the next step, is to actually recode all of the data. So what this does is it takes in and reads each of these imputed data objects in separately. It then splits it up by data, by imputation, recodes it, and then resaves it. And you'll see what I mean here in a moment. So highlight this and run. And this is, unfortunately, takes a pretty long time, unfortunately. So what you'll see in here is that it is starting to print out these new files called recoded imputed data underscore imp1.rds. And it does this for every country and every imputation requested. And so that's why it kind of takes a quite a long time, because it has to pull in the data, recode the data, and spit it out. And it does it relatively fast per every imputation, but we have 23 times 20, which is a large number of files. One thing you'll notice is that the files are different sizes for the different countries, and sometimes they're even slightly different for the different imputations, and that's okay. There's nothing wrong is happening, but one of the reasons why we ended up needing to kind of separate all these files in this way was to not overload the memory of individual computers. Okay, after running the recoding, you'll see that we got all of these new files. There's a lot. You'll see it took, on my computer, about an hour, I think. Yeah, well, about almost an hour. So it's not too long, but it's just a little tedious. So the next big thing we want to do is we want to check to see if things were recoded correctly. So the first thing we do is we actually just create these temporary files, and we look to see what happened with our data. So we have the raw data on the rows, and we got the recoded data across the columns. You'll see that there's no missing variable on the top, but there's only a few missing responses down below. And yep, it looks like we are good to go here, but this becomes really important to double check for any categorical or collapsed analyses, so that you can really just make sure that the raw data labels got mapped to the 0, 1, or reversed if needed, like for the loneliness variable. Okay, the next major step is running the attrition weights model. This is very similar to the imputation model, where we read in like what takes the data, well, it takes the directory where all the data files are stored, specifically all the recoded ones, and what it does is it uses all of these variables to predict whether a person is likely to stay in the study at wave 2. And then you use that to create a weight on the back end. So what we do is rerun that, and this takes a little while. So we run it, and what you'll notice when you run it is it creates this new folder called results ATTR, or attrition for short, and it starts to it will start to create output files here once it starts once it finishes the analyses. But it's just a way of kind of taking in a different way to account for the effects of missingness in our analyses. Okay, now we got those attrition models ran. See if they're all in here. You'll notice that the United States file is much bigger. Okay, so this next part now actually takes all of those attrition files, goes into them, computes the weights that are needed, and appends them to the restructured and recoded imputed data. So this is just going through basically all of these files over here on the right and adding them as needed to all of these recoded files. And now we highlight that and run. You'll see that it does a join here, and it does a join for every single data set because it does the match on the country, the imputation, the person ID, the strata, and the PSU cluster ID. Basically doing everything we can to make sure they match up. Okay, now that that is finally over, it shouldn't take too long. What we can do now is we actually want to remove the raw data set so that we can clean up ours memory a little bit, so we get a little bit of it back so that we can run our analysis still a little bit faster. So the analyses are run in part 7 by loading up all of these recoded variables. So you just kind of highlight all of those and run them. This is something that I'll delete because you don't need it. I was doing that when I was running just a small subset of variables. You don't need this, that, or that. There were some weird issues that we had when we ran these analyses due to how the future package interacted with the now all the analyses. But the nice part is that all of these are kind of taken care of under the hood, so you don't actually have to worry too much about them. But a big part of it is using this plan thing from the future package in order to kind of set up using multiple cores to do things in parallel. This part is just these lines 29 and 30. They're just about how do we provide an update of like what printing out kind of along the way. What you'll notice is that we have to reload all the packages and we need to reset this option inside the walk. There's some weird things about it. And the major workhorse is this GFS run regression for single outcome function. This is the function that essentially runs all of the country level analyses and then spits them all out into a new file. We have it set up so where we know we have to say where the raw data is for the analysis, or reformatted data is for the analysis. We say like what weight, what our PSU is, what are the kind of default set of covariates we're using, which we set up here, and what are all the potential confounders. This we don't technically need for this set run because we don't include principal components. So there's several different options for using the principal components. The first set of analyses we run without them, and we save them to the file called results primary, which will be created automatically for us, which is nice. And all of those files will have this same appendix or appended text at the end. So without further ado, I'll show you. You just kind of highlight it all and press run. What you'll notice that it gives you a progress bar to help you kind of see where everything is at. First thing you'll notice is that now we have the results primary file, and nothing currently is being displayed, but soon it will be, which is nice. Okay, you see that the first outcome was already complete. So it was the outcome for happy 1. Well, it's not completed, but it's being printed out. What you'll notice is that in these files, they actually get updated as they go, which is really kind of a nice way that we set it up, so that the results get printed out and updated as they go, so that no one file is too large. Okay, and when it's done, you'll see that there are now a ton of files. One of the big things we have to do now that that is complete is we now need to run the meta-analyses to get the meta-analyze results and forest points. One of the things about the analyses is there are 2 sets that are conducted. One is the unstandardized estimates and the standardized. So you get not only the estimated standardized effects, but also those that are based on the kind of raw score without standardization, which allows for comparison to results from the wave 1 analyses. And thankfully the meta-analyses run generally pretty quick, and I would not worry about, there's a lot of warnings that are fine. In nearly all cases, warnings don't mean something was wrong. It just means that there was just one of the estimates was really precise while one of them was not. I found that happens a lot with the education outcome, because there wasn't really much change in education from wave 1 to wave 2. at least not always, not in a lot of countries. So essentially, after we control for wave 1 or baseline education, all the other effects basically become 0. Or the effects are at least very precise. And then we do the same thing, but for the analysis with principal components. This is the exact same where we just kind of highlight it all. One thing we can do to make the code a little bit smaller and easier to highlight and use is we can just press this little arrow because it collapses it, and you can just highlight and press run the exact same way. Now I've already ran this to help kind of speed up our process or my video, and now I'll just run the meta-analyses for those. Thing we have to do right after those meta-analyses run is we run our supplemental kind of sensitivity-like analysis of the result when we use kind of a complete case-like analysis. It's not 100% complete case, because what would happen is we'd lose basically everyone in our sample. At least several countries would go to 0, and we need to include as many people as we can. And so that it's complete in the sense that they responded at wave 1 and wave 2, but not complete in the sense that every observation is observed. So it uses the exact same code that we did for the input analyses, but the thing that changes is what weight we use, and the fact that we're using only a subset of the cases, specifically the cases that were observed at wave 2. And the way we wrote the package in the R is you can actually subset the data in 2 different ways. One, which is what is done here, which is what I call a direct subset, where we just remove all of the cases that aren't observed, and then we use the updated sampling weight. The other approach, which I'll probably make another video about later, is regards using the domain, subdomain estimation approach, which is different. And then we run that, which I already did to help save time. Set up the meta-analysis results. Then we do the exact same thing for the principal component results. Okay, now that is it for running the analyses. Once you get past here, you are once you get up to about almost line 500, you have run all of the analyses. The problem is now turns to spitting those analyses out, which we do here in this last part, where we read in the data again, and we have to, this time, append the attrition weights. I add in these 2 options into the get the raw data. This is adding white space, and this is making sure that some of the variables are reverse coded as needed, such as the loneliness variable, which wasn't the default in the other command due to the way we did the imputation. And all this is the exact same. There's a lot of additional arguments to these 2 functions. One generates the main documents with the summary table, the meta-analysis results, the